we're going to go ahead and do some testing with air-fuel ratio sensors. The car that we're going to use is a 2007 Lexus. Before I even go any further and start testing, let's talk about a few things you need to know first. Air-fuel ratio sensors work completely different than that of an O2 sensor. Real quick, like, an air-fuel ratio sensor is a 0 to 5 volt range. At 3.3 volts, it's at stoichiometric, always saying 14.7. And what's going to happen is I go ahead and I add fuel, snap the throttle and it goes rich, the voltage will fall to around 2.5 volts. As I go ahead and let go of the throttle, what's going to happen is you'll notice that the air-fuel ratio sensor's voltage will rise. It works completely opposite of an O2 sensor. Remember, in a lean condition on an O2 sensor, you were looking at 0 volts. When I'm looking at a lean condition on an air-fuel ratio sensor, it's opposite. It's high voltage. When looking at a rich condition with an O2 sensor, we're looking at 1 volt. When looking at a rich condition with an air-fuel ratio sensor, it's low voltage, around 2.5. So to begin, let's talk about the test procedures. The first thing you always must check for is diagnostic trouble codes. Do I have a diagnostic trouble code for an air-fuel ratio sensor heater? If you do, you must repair that first. Don't go ahead and start testing an air-fuel ratio sensor until you've done that repair. Second, never ever use propane enrichment to do air-fuel ratio sensor testing. If there's any possibility of doing damage to the air-fuel ratio sensor heater by adding propane, you probably will do it. So let's go ahead and do a test. First, I've got to go ahead and set up the scan tool to look at this vehicle. So I'll tap Select Vehicle, and then I'm going to go ahead and tap Start Auto ID. Up will come our warning screen, and then I'm going to tap on OK, and in a moment it will determine what exact vehicle we are working on. It selects the VIN for us, right through using mode 9. You'll notice it tells us there's 2 Lexuses there. We got a base and an advanced model, so I'll tap on base because that's what this particular Lexus is. And now up comes my controller page. We're going to go ahead and do testing, but as I said earlier, you can test both using Global OBD2, or if I happen to be working with a Toyota, I can go into the Toyota or Lexus specific test that we're going to do a little bit later. At this point, I'm just going to go ahead and tap on Engine because I want to deal with OEM just to make it easier for me. And we're going to look at the air-fuel ratio sensor in data stream. You could look at that in Global OBD2, so remember that I can test any one of the tests I'm going to show you today, except for the Toyota specific, in Global OBD2. I'll tap on Engine. I'll tap on the warning screen, OK. And in a moment, opens our test procedures. Once they go white, we'll tap on Data Stream. Up comes my various groups. And what's really nice about Toyota and Lexus is I have all data items. So I'm going to tap on that. We'll hit Select. And I'm going to go ahead and tap on Vertical so I can scroll up and down vertically. And now it's going to load. Our data stream is now up, so let's go ahead and select our 2 PIDs that we're going to work with. Remember, putting in the least amount of PIDs on the scan tool screen makes the tool the fastest possible refresh rate that you can use. So I'm going to select what I need. In this case, I'm looking for air-fuel ratio sensor bank 1 sensor 1 and air-fuel ratio sensor bank 2 sensor 1. So I'm going to tap on that, and I'll put a check mark in each one. Now you notice I have both of the ones I want selected. Air-fuel ratio sensor bank 1 sensor 1, air-fuel ratio sensor bank 2 sensor 1, both in voltage. So I'm going to go ahead and tap on the up arrow where I select A to Z. I'll tap on View Selected Only. Up comes my 2 PIDs. So let's go ahead and do one thing. Let's increase the size so I can get it to the largest possible size for myself to look at. So I'm going to go ahead and use the 2 arrows going away from each other. It increases the size once. Now I'm going to pinch it from the center out, increasing it again. Now I can look at my data stream items at the largest possible size for myself. So looking at the 2, you'll notice that my air-fuel ratio sensor is switching rich to lean. When I start doing my test, what I'm looking for is a change. If the air-fuel ratio sensor value changes when I do my testing, I know the air-fuel ratio sensor is working. The first test I'm going to do is I'm going to create an intake leak, a vacuum leak. So I'm going to go under the hood, and I'm going to create a vacuum leak. And when I do, you should watch for your air-fuel ratio sensor voltage to rise because I created a lean condition. So let's go ahead and create that vacuum leak. Remember, as I said, when I create the vacuum leak, I'm going to go lean for a while, so you'll see the voltage rise, and then as the controller sees a lean condition or a vacuum leak, it will automatically try to correct by adding fuel. So watch what happens. As I create the vacuum leak, you'll see your voltage rises, and now you'll watch the controller make the change where it's trying to do a corrective action. So we know that we got a switch point and we know it's working. So let's rehook up our vacuum hose and fix the vacuum leak that we created. This has now told us the air-fuel ratio sensor works well or in good working order. Let's go look at another way to test that by going inside the car and doing another type of test. Let's go ahead and do a second test for the air-fuel ratio sensor, but this time I need to be in the car because I got to use the throttle. What I'm going to do is I'm going to bring the engine RPM up to 2,500 RPM and hold it steady. You should notice that the air-fuel ratio sensor voltage should be around about 3.3 volts, moving up and down a little bit. Then what I'm going to do is snap the throttle to around 4 grand, all the way wide open. When I do, you'll notice that my air-fuel ratio sensor voltage will fall rich. And then as I close the throttle, you'll notice that your air-fuel ratio sensor will rise lean. Remember, again, it's opposite of what the O2 sensor does. 1 volt being rich on an O2 sensor, 0 volts being lean on an O2 sensor. In the case of an air-fuel ratio sensor, it's opposite. It's going to be 4 volts, which will be lean, and it'll be 2.5 volts, which will be rich. So let's go ahead and perform that test. During that test, I'm going to try to talk, but it'll be wide open throttle, so you may not hear me. So I'm going to point to the scan tool so you can see the changes in data stream. So I'm going to bring it up to 2,500 RPM and hold it. And that's only approximately 2,500. You don't have to be exact. You notice that I'm around 3.3 volts, and it's just switching nicely. When I go ahead and snap the throttle wide open, see how the air-fuel ratio voltage fell off rich and then rose to the lean condition, which tells me with the change that was going on that my air-fuel ratio sensor worked perfectly. You've just seen 2 scenarios where I actually did air-fuel ratio sensor testing on OEM data stream, but I could also use Global OBD2. This test can be done on anything from a Toyota to a Ford to a Lexus to a Kia. Whatever car has an air-fuel ratio sensor, you can use Global OBD2 or OEM data stream. But now let me show you a Toyota specific test. I'm going to tap on the home button, and now we're going to go to special tests. Once again, this is only a Toyota test. This is only available for Toyota and Lexus. So when special tests opens up, we'll go ahead and perform that Toyota specific test. So now what we're going to do is we're going to scroll up looking for fuel systems tests, and we'll go right into injector tests, and you'll see that we have control the injection volume for air-fuel ratio sensor. Again, I'm in special tests. Toyota and Lexus have a specific test that they use in special tests where you can drive the air-fuel ratio sensor rich or lean by increasing or decreasing injector volume. The car's controller will do this test for you automatically. What's going to happen is you're going to see that the air-fuel ratio sensor in milliamps will rise to positive current. What happened then is, as a result, the injector pulse width volume went rich. So as a result, the air-fuel ratio sensor saw the rich condition, and when it does that, it's going to try to bring it back to stoichiometric of 3.3 volts by increasing the current to the air-fuel ratio sensor. And then what will happen is the car's controller will then drive the injector pulse width volume to a leaner condition, and at the same time, it will physically see the air-fuel ratio voltage rise. So now what will happen is I'll see that I have air-fuel ratio current at a negative position, where it's going to try to reduce the voltage from 4 volts back down to 3.3 volts. So let's go ahead and start the test. I'll hit on. When you do, now the injector pulse width will start to go wide. You'll notice that my air-fuel ratio sensor milliamps are rising to bring the air-fuel ratio sensor back to 3.3 volts from 2.5, and then it goes down to a negative 0.11 milliamps to go ahead and bring it back to 3.3 volts again. So it went to a lean condition of 4 volts, it reduced the current to bring it back to 3.3 volts. Once the test is completed, we can then go ahead and see that we did have a change like we saw, and the test has performed successful, telling us that the air-fuel ratio sensor is in good working order. Now we're going to do one more test on this particular car, and then we're going to move to a different one. I've already set the scan tool up for this particular test, but what I'm going to do is show you how to test a mass airflow sensor using data stream. There's many ways to do this. Volumetric efficiency test, which we talked about in a previous class, but we're going to talk about in this particular one, verifying if the mass airflow sensor itself needs some issues. All right, first up, you always want to bring up the mass airflow sensor in data stream. This particular car has 2 mass airflow sensors, one for each bank. I've got mass airflow sensor bank 1, mass airflow sensor bank 2. So what I'm going to do is I'm going to look at my mass airflow parameter at idle. you'll notice that we're somewhere around 2.9 grams per second. Your mass airflow sensor at idle should be somewhere between 2 to 5 or 2 to 7 grams per second. And then what I'm going to do is I'm going to increase the engine RPM all the way up towards 2,500 to 3,000 RPM or higher and see where my mass airflow sensor is. It should rise nice and smooth and nice and linear. So you should see a nice smooth rise as I slowly bring the RPM up, but at the same time I should see my mass airflow sensor start out around 9 to 15 to 25 grams per second depending on the engine size. So let's go ahead and do that. You notice it's nice and smooth rising. We're rising nice and linear, very smooth on both mass airflows, and we're slowly getting closer to the RPM range we want to be. And we're moving up towards 3,000 RPM. And now you notice that my mass airflow sensor is looking at around 10 grams per second. A nice linear smooth rise. Don't worry about the little bit of glitches in there because that's where my foot wasn't perfectly smooth going up or my air volume wasn't smooth going in. So now we look at it, we notice that my mass airflow sensor is reading around about 11 grams per second at approximately 3,000 RPM. We know that mass airflow sensor works fine. We know that it's seeing the change in air volume. We know that it's going up nice and linear and nice and smooth. So let's go and let it bring it back to idle. Now that test is completed, let's go ahead and move on to another vehicle. We're back on another car. This is a 2015 Ford Fiesta, and I'm going to show you some testing with the scan tool without ever opening the hood, using the scan tool to do some basic testing that you would have to go get other equipment to do the tests for. For example, I'm going to show you how to do a charging systems test, battery test. I'm also going to show you how to do a catalytic converter test and a throttle position sensor test without ever opening the hood, without ever going to Ford OEM software, because we're going to go right to OBD2 from the main menu right here. So I'll tap on OBD2. I'm going to get in the car while the scan tool pops up. Now that we're in generic OBD2, let's go to data stream mode 1, and we're going to pick vertical scrolling. And we'll scroll looking for our data stream items that we want to test. Remember, I told you we're going to do 3 separate tests. I'm going to set up the scan tool for all 3 tests at once. We're going to do a TPS test, then we're going to do a cranking battery test, and then we're going to do a catalytic converter test. So let's look at our data stream. First thing we're going to grab onto will be TPS as I look for it. Put a check mark in that. And then I'm going to scroll and look for calculated load. There it is. Because this car is not equipped with a map sensor, so I'm going to use calculated load. We'll talk about that in a minute. And then I'm going to go ahead and look for module voltage. There's control module voltage. Now I've got all 3 of my PIDs. We'll talk about the control module voltage and what you select in a few minutes, but let me just continue to select up the scan tool. I got 3 PIDs. I'm going to tap on the A to Z up arrow. I'll hit View Only Selected, and we're going to get set up to do each individual test. To do that, I'm going to go ahead and expand the size of the PID, and I'm going to squeeze from the center out, and once again, until we get to the largest point. Now the first test we're going to do is the battery charging systems test. I selected control module voltage. Depending on the car, depending on the test procedure you're doing, you can either select battery voltage, ignition voltage, control module voltage, or if you have neither of those, go ahead and select charging system amperage. At this point in time, you'll notice that my battery voltage is around 12.18. What I'm going to do now is I'm going to put the car into a no start condition. Depending on the brand of the car and the type of car, you can either use clear flood where I put my foot to the floor. Obviously with that, the engine needs to be at a cooler than normal operating temperature. I don't want it at hot temperature, because in hot temperature it won't go to clear flood. In other words, if it's at operating temperature, it won't do that. If I'm dealing with a Ford, I could take the inertia switch and take your fist and knock it real hard until the red button pops up. Or I can go ahead and pull the fuel pump relay, whatever you want to deal with. In this case, what I'm going to do is go put my foot to the floor, because this car is equipped with clear flood, and I'm going to go ahead and crank it. And when I'm ready to start cranking, I'll hit the timer. I'll hit the start. And when I get to 15 seconds, I'll let go of the throttle, and it'll start. I'll go ahead and turn on all the accessories, headlights, AC, window defroster, and I should see my battery voltage rise to above 13 volts, 13.3 and higher. In this case, we hit 13.9. A review of the charging systems test, just so you understand what we did. First, we put the car into a no-start condition called clear flood in this case. If you were dealing with another type of Ford, you may have to use the inertia switch, or any other brand, you may have to actually pull the fuel pump relay. Then we cranked the engine for 15 seconds. During the crank, you were pulling the battery down to its lowest point for starting. It should never drop below 11.2 volts. It got to 11.4, so this battery is probably okay, but it's getting tired. And then you're going to go ahead and let go of the throttle so the vehicle starts, and you're going to keep cranking until it starts. Once it starts, you're going to go ahead and turn on every accessory, and you're going to turn on the headlights and bring your engine RPM up. When you do, you should see your battery voltage rise to over 13 volts. We were successful with this test. Everything checked out fine. So now let's go ahead and look at doing a catalytic converter test. So as I told you, the scan tool is already set up for the right data stream items. I'm going to scroll down until I find my calculated engine load. I've got calculated engine load in bar graph right now. You can put it in graph mode or bar graph, however you want to deal with it. Whatever's easiest for you. However, let's talk about two things here. We are physically doing a catalytic converter test. One of the things during a catalytic converter test is to remember that you need to look at either map voltage or calculated load, depending on what you deal with, what you want. If the car is equipped with a map sensor, great. If the car has calculated load in generic or global OBD2, you can use that as well, because calculated map voltage will do the same test as a regular map sensor. If you don't have either, then we can use calculated load. Typically, in this case, calculated load will be between 20 and 50% at idle. During the test, we're going to bring the engine up to about 2,000 RPM and see where our calculated load is. If you had a map sensor, I would be looking between 1.2 to 1.6 volts. If I had a calculated load, I'd be looking between 20 and 50%. Then I'm going to snap the throttle wide open. When I snap the throttle wide open, the map voltage should go all the way to 3.9 to 4.6 volts. If I were using a calculated load like I am in this case, my calculated load will go all the way to 100%. When I let go of the throttle, my calculated load will drop to 0. My map voltage will drop to about 0.8. When I let go of that throttle, I should watch for the amount of time it takes for that calculated load to return from the 0 or the 0.8 volts back to the 1.2 to 1.6 volts on map sensor, or from 0% on calculated load back to the 20 to 50% load in less than 3 seconds. So let's go ahead and do that. I'm going to bring it up to about 2,500 RPM. Our calculated load is at 20%. I'm going to snap it wide open. It went to 100%, and you notice it dropped down below the 20, and it returned back to the 40% in less than 3 seconds. If I were dealing with a map sensor with map voltage, you would have been at 1.2 to 1.6 volts at 2,500 RPM roughly. And when you snap the voltage, you snap the throttle, the map sensor would have gone to 3.9 to 4.6 volts. When I let go of the throttle, the map voltage would have dropped to 0.8. In this case, we know that our catalytic converter is not plugged up. It's working properly. We were testing for a plugged catalytic converter. So now let's go ahead into our third scenario. And for that, I'm going to turn the key off and then back to the on position. And I'm going to go back and we're going to look at throttle position sensor. Now, throttle position sensor right now is in bar graph. I want that in graph, so I'll tap on 3 dots. I'm going to tap on line graph. And what I'm going to do is I'm going to slowly open the throttle and slowly close it, looking for a nice, smooth, linear line on the scan tool. It should rise nice and smooth. If it does, if we have a throttle position sensor fault code, we know the throttle position sensor is probably okay. So let's go ahead and bring it up slowly, and you'll notice it'll move up very, very slowly. And you know it's a little bit notchy right now because we're just breaking in the ice. I'm only at about 21%. And remember, you can use PPS voltage or you can use percentage. And as you slowly open it up and down, we'll look for a smooth linear rise, which is what we're getting. Every notch is about the same. I'm going relatively slow until I get to wide open. And now I'm going to let it come back down. I'm going to do that again for you so you can see it. Now let's do it again. Once more. See how it's smooth up, nice and smooth and linear rise. And I'm going to bring it back down. So we know that our throttle position sensor is good. In this scenario, we checked for a throttle position sensor fault code, maybe a glitch where the car was hesitating going down the road or whatever, and we found that our TPS was in good working order. In the near future, we'll bring out some more test procedures for you in another video later on down the road. But in the meantime, as we'll tell you exactly how to get the class to help you learn how to use all these test procedures. We'll tell you the email to go ahead and send to get a copy of the class.